Once again, hearty welcome to the Math Revision Made Meticulous video series. Topic: Application of derivatives. At this video, you will see some practical problems on maxima and minima. You can call them as word problems. Revision, as the name suggests, means looking back over previously learned information, ensuring that it is clear and fresh in the mind. 5 questions per video from selected topic is presented at this video series. The steps in answers are supported by the ideas used for getting the answers. How to tackle practical problem on maxima minima? The given quantity in the given problem is to be taken as a constant. If they were given for a given perimeter, given area, given volume, given height, like that it is given, that should be taken as a constant. And you know that what do you mean by taking it as a constant? While you are doing differentiation, you have to keep it as a constant. Well, express the variable to be maximized or minimized in one variable. Suppose volume to be expressed in terms of a single variable, surface area to be expressed in terms of a single variable, everything to be expressed in terms of a single variable using the condition given in the problem. Some condition will be given in the problem to express one variable in terms of the other. You have to select and use the second derivative test to check the local maxima or local minimum. Maximum you have to use second derivative, and all of you know that if second derivative fails, we will go for first derivative. Calculate the absolute maxima or absolute minimum value, and we are doing local maxima minima. As there are only one local maxima minima, it will become absolute automatically. Now we will have problems of different types. First, let us take problem of numbers. We have to take two positive numbers whose sum is 60 and product of the squares of the number is maximum. When two numbers are 60, we have to take the numbers as x and 60 minus x. I am expressing both of them in terms of x only. Let p be the product of the squares. Therefore, x square into 60 minus x the whole square. You have to differentiate it. Keep x square, differentiate 60 minus x the whole square. Keep 60 minus x the whole square and differentiate x square. But you will get this minus 2x square into 60 minus x plus 2x into 60 minus x the whole square. This is first derivative. We equate it to 0. 60 minus x can be taken outside. For you will get 60 minus x, x into 60 minus x into 60 minus 2x is equal to 0. Now out of them, x cannot be 0 because positive number given, and 60 minus x cannot be 0 because the sum is 60. Therefore, the only possibility is 60 minus 2x is equal to 0. Therefore, x is equal to 30. Now, let us find the second derivative. Once again, we have to use the product rule. I am keeping minus 2 outside and differentiating x square into minus 1 plus 60 minus x into 2x like that. And I am simplifying it. This is a normal differentiation. And I am not simplifying it because I am going to put the value of the second derivative at x is equal to 30. I have to check, and I am putting the values. I am simplifying. I am getting, no need to do the total simplification. You are getting minus 2 into 900 plus 2 into minus 900. It should be less than 0. If our product is maximum when x is equal to 30. For what will happen when x is equal to 30? The other number will be 60 minus 30. Therefore, it is 30. Therefore, the numbers are 30 and 30. Therefore, when x is equal, the numbers are 30 and 30, the product of the squares of the number will be maximum. Let us move on to the question involving right angle triangle. You have to prove that the area of the right angle triangle of the given hypotenuse. Please understand, given hypotenuse is maximum when the triangle is isosceles. Let me take the idea that the hypotenuse is given, therefore that should be taken as a constant. So let us take L as the constant. Therefore, L is the hypotenuse. And I will take the base and the height now for to get the area. Let me call x as the base, and by using Pythagoras theorem, root L square minus x square will be the height. Now I have expressed both altitude and base in terms of x only, where L is a constant. Now what will be the area now? Area is half into base into height. Therefore, x into root L square minus x square multiplied by 1 by 2. Now we have to differentiate it. Keep first x, differentiate root L square minus x square. Keep root L square minus x square and differentiate x. What is the differentiation of square root? 1 by 2 into that square root into d by dx of L square minus x square. That will be 2x. 2 and 2 will get cancelled, and we are getting minus x square upon root L square minus x square plus square root of L square minus x square. We will take LCM now. When you take LCM as square root of L square minus x square, this is a kind of simplification because we have to simplify, then only we can equate it to 0. The numerator becomes minus 2x square plus L square upon square root of L square minus x square, and half is outside. What will happen when you equate it to 0? Numerator will be 0. Therefore, minus 2x square plus L square is equal to 0. Therefore, 2x square is equal to L square, and therefore you are getting x is equal to L by root 2. Therefore, x is equal to L by root 2. We want the value of x. And I have dA by dx now, and I have x as L by root 2. Now I have to check the nature of double derivative. That is the second derivative at this x is equal to L by 2. Again differentiate it. Again use UBV form. Then denominator whole square. Denominator into differentiation of the numerator minus numerator into differentiation of the denominator. Then the numerator differentiation is very simple. It is minus 4x. Differentiation of the denominator, that is square root of L square minus x square, is 1 by 2 into root L square minus x square into d by dx of it, that is. Let us continue of simplification of this second derivative, and 2 and 2 getting cancelled. Therefore, the numerator will become root L square minus x square into minus 4x plus minus 2x square plus L square multiplied by x upon that square root L square minus x square. Let us take that root L square minus x square as the LCM in the numerator. So it will become L square minus x square into minus 4x plus x into minus 2x square plus L square. That square root of L square minus x square will get multiplied with the denominator root L square minus x square the whole square. It will become L square minus x square whole power 3 by 2. Okay, let us continue. Let us simplify the numerator. When I simplify the numerator, it will become 2x cube minus 3L square x. Now I have to check the value of this second derivative at x is equal to L by 2. Wherever x comes, I am replacing it by L by root 2. 2 into L by root 2 whole cube minus 3L square into L by root 2 by divided by the denominator. Now in the numerator, I am getting 2L cube by root 2 minus 3L cube by root 2. Simply by seeing it, no need for any more calculation. I am finding that the numerator will be a negative number, that is 2L cube minus 3L cube. Therefore, it will be minus L cube. L cannot be negative. It is a hypotenuse, and denominator cannot be negative because L square by 2 whole power 3 by 2, that also cannot be negative. Therefore, d square a by dx square is less than 0 at x is equal to L by root 2. What is the conclusion? Area is maximum by the second derivative test when x is equal to L by root 2. What will happen when x is L by root 2? Height is L square minus x square under square root. Therefore, it is L square minus L square by 2. Therefore, this answer is also L by root 2. Therefore, length is also L by root 2. Height is also L by root 2. Therefore, when the area is maximum, the right angle triangle will be an isosceles right angled triangle. Let us move on to the next question. Show that the cylindrical vessel of given volume has the least surface area when the height is twice its radius. Already I told you, whenever you are having problem involving cylinder and cone, be careful. There are two variables in the formulae. There will be a clue given in the problem to express one in terms of the other. But you should be very clear than which to be expressed for your convenience. Let us see. Cone is given, R is the radius and H is the height. And V will be the volume of the cylinder. And volume is given, therefore volume to be taken as a constant. Volume given. Now what is the formula for volume? Pi r square h. Now by making use of the given idea that volume is given to you, now you can express either r in terms of h or h in terms of r. But for our convenience, let us select h as v by pi r square. H is equal to v upon pi r square. Now what is the surface area formula? It is 2 pi r h plus 2 pi r square. For this only I have selected h. If I take r, then square root will come. Therefore I am avoiding it. Therefore I will substitute h here. 2 pi r into v by pi r square plus 2 pi r square. Simplify. It will become 2v by r plus 2 pi r square. Now surface area has been expressed in terms of a single variable r, and capital V is a constant over here. I can differentiate with respect to r now. ds by dr is equal to 2v into 1 by r differentiation is minus 1 by r square differentiation is 2r with respect to r. But you are getting ds by dr as minus 2v by r square plus 4 pi r. I continue, equate it to, okay, again differentiate it. Differentiation of 1 by r square is minus 2 by r cube, 4 pi r differentiation is 4 pi. Let us keep it ready. And when I equate the ds by dr to 0, I am getting 2v by r square is equal to 4 pi r, r2v is equal to 4 pi r cube, therefore r cube is 2v by 4 pi. Let us keep this as r cube only, and no need to have r, it will become a cube root. Therefore r cube is v by 2 pi by simplifying. Now we are getting second derivative we are having and r cube we are having. Substitute it. When you substitute, I will get 4 pi upon v by 2 pi plus 4 pi. No need to do any calculation. All quantities are positive, it is greater than 0. What will happen if the second derivative is positive? Then it will be the minimum. When r cube is v by 2 pi, the surface area is minimum. Okay, now let us continue. Now r cube is v by 2 pi. What is the formula for h? The r cube is equal to pi r square h by 2 pi. Already we have found it. V is pi r square h. Now, what will happen when you do the calculations? R square, r cube and r square, r will get cancelled and pi will get cancelled. Therefore 2r is equal to h. What is the meaning of 2r is equal to h? Height is twice the radius. Therefore, for the cylinder of the given volume, when the surface area is minimum, then the height is twice the radius, or height is equal to diameter, whatever you call. Therefore, we have proved that when volume is given, surface area will be minimum when the height is twice the radius. Now let us go to the next question from problem involving two solid figures. Volume of the largest cone that can be inscribed in a sphere of radius capital R is 8 by 27 of the volume of the sphere. Very, very important problem. And I have taken the sphere and one cone is inscribed, and I am taking capital R as the radius of the sphere. Therefore, radius of the sphere is given. Therefore, radius capital R should be taken as a constant. Let small r be the radius of the inscribed cone and h be the height. Therefore, from the figure, BC is equal to r. H is the height. Therefore, I am taking that BD is equal to h. And therefore, when you want to find that AB, it will be h minus capital R. Very simple, h minus capital R. Because AD is capital R, therefore h minus R. Now, from the triangle, BC square is AC square minus AB square using Pythagoras theorem. Therefore, small r square I am finding. Therefore, I want to express r square in terms of h and capital R. For one variable expressed in terms of the other variable. Now, all of you can think that height can be expressed in terms of radius, radius can be expressed in terms of height, but here you have been asked to show that the volume is having r square formula. Therefore, I am expressing r square in terms of h and capital R. Capital R is a constant here. Well, now let us move on to volume formula. It is 1 by 3 pi r square h. I am having a formula for r square already. I am substituting it. I am getting this is the expression for volume in terms of h only. Therefore, I will differentiate with respect to h now. For when I differentiate with respect to h, 2h square r differentiation is 2r into 2h. h cube differentiation is 3x square. Therefore, I am getting dv by dh now. Again, I will differentiate normal differentiation 4r minus 6h. I will equate dv by dh is equal to 0. When I equate it to 0, I am getting h is equal to 4r by 3. Therefore, this is the second derivative, and I already found that h is equal to 4r by 3. I will put it in d square y by dh square, and I am getting 4r minus 8r. No more simplification required. It is automatically less than 0. What will happen when the second derivative is less than 0? It is maximum. Volume is maximum at h is equal to 4r by 3. Therefore, now we have to prove that this volume is 8 by 27 of the volume of the sphere. Therefore, this is the maximum volume, 1 by 3 pi r square h. Therefore, this is the maximum volume, pi into h square into 2r minus h. Therefore, I am substituting now h is equal to 4r by 3, and I am getting it as pi by 27, 16r square into 6r minus 4r, which is nothing but 2r by 3. Now I have to do some adjustments so that I will get the formula of the sphere. sphere formula is 4 by 3 pi r cube. Therefore, we will just see that substitute it as 8 by 27 and collecting it, and 2 into 2r square by 3 is 4 by 3 pi r cube. Good. Therefore, I am getting it as 8 by 27 into formula for volume of the sphere if capital R is the radius of the sphere. Therefore, if the volume is maximum, the volume of the cone is equal to 8 by 27 into volume of the sphere. Let us move on to the question involving parabola. Find the point on the curve which is nearest to the point. We have to use distance formula. Let me take P as the point on the curve, and capital D is the distance between the point and the given point minus 1 comma 2, and D is given by this distance formula. But to make the differentiation simple, let me take f of x as d square, so that square it will go. But this is f of x. I have to find f dash of x now. Before we go for that, f of x to be expressed in terms of x only, y is nothing but x square by 4. Well, therefore I am expanding it now. X plus 1 whole square I have expanded, x square by 4 minus 2 also expanded. I am collecting all the terms. Therefore, f of x is x power 4 by 16 plus 2x plus 5. What do you have to do? Differentiate it. 1 by 16 into 4x cube plus 2. Therefore, f dash of x is x cube by 4 plus 2. Now, f double dash of x is very simple. It is 1 by 4 into 3x square. If f dash of x is 0, we have to find what is the value of x. X cube is minus 8. Therefore, x is minus 2. Cube root of minus 8 is minus 2. Therefore, at x is equal to minus 2, f double dash of minus 2 you are finding. Therefore, at x is equal to minus 2, f double dash of minus 2 is greater than 0. For when x is equal to minus 2, the distance will be minimum because the second derivative is coming as positive. What will happen when x is equal to minus 2? I am getting the value of y, which is x square by 4. Therefore, it is 1. Therefore, the point on the curve which is nearest to the point minus 1 comma 2 is minus 2 comma 1. We are seeing the graph of it. Therefore, for the point minus 2 comma 1, the nearest point is minus 1 comma 2. Success is dependent on efforts. All the best. Thank you.